Thanks for tuning in. My name is Lawrence Lai, and I'm an Insight Data Engineering Fellow of June 2019, Boston. The title of my talk is going to be Conversation Headline Analytics Tool. This is the project title where I analyze many chat rooms, as a result the acronym. The premise of this project is based on the traffic of chat rooms. In modern media, there are many platforms that feature video broadcasts accompanied by a chat room where the audience members can engage the content creators. One of these platforms is Twitch TV, a very popular video game broadcasting platform. And through my measurements, I found that Twitch TV has roughly 2,000 messages per minute across all the different channels. To the right, I show the chat messages in a particular channel. You can see that there are many messages within the same minute timestamp. As a content creator, you might be oftentimes very focused on creating your content and unable to read many messages at a time. And as a result, the objective of this tool is for content creators to monitor their chat by outputting a message count every 5 seconds and classifying chat sentiment between question, funny, disappointment, and neutral. Reasoning behind these 4 sentiments is question often requires the content creator to reply. Funny means that the content creator is doing well. Disappointment means that the content creator should change the type of material they are producing, and neutral is a catch-all phrase for everything else. For the approach of my project, we will begin with a chatbot that records and logs messages from over 100 channels. This will be passed to a processing script where messages are being counted and the behavior will be classified using a deep learning model trained on 2,000 chat messages. Then we output the message traffic and chat behavior with respect to time. So this is what the tool looks like. On the back end, we are taking messages using our Stream Chat bot, and we can see these messages go through at a very high traffic. It's impossible to read any of these lines without scrolling up. And as a content creator who's creating video content, this would be even harder. And in response to that, my processing script processes the chat content in the following format. You can see on the time that there is a batch of outputs every 5 seconds with channel names associated and the number of messages associated in the last 5 seconds. You also see the number of messages that are classified based on the 4 sentiments: question, disappointment, funny, and neutral. Right here is a display of our Chrome extension. So you can see on the extensions page, the extension doesn't really do anything. But as we go to a Twitch TV URL, the pop-up activates and you will be able to monitor the chat behavior of this channel. We are looking at XQCow right now, and on the y-axis we have number of messages, x-axis we have timestamps. You can see that with respect to time, the number of messages for XQCow have been increasing in the last 30 seconds, and it's very likely that there's content being created that prompts for more audience responses. This is Summer Games Done Quick of 2019. You can see that the chat traffic is much lower than the previous channel, but there's a more diverse set of responses, chat sentiments that are associated to this channel. The back end of my work is powered by these tools. First, the data source is by the chatbot written in Node.js. The reasoning for using this tool is because of the pre-existing tool provided by Twitch TV. Up next, we have Kafka for ingestion. The chatbot outputs to Kafka, and the reason for using Kafka is because it's scalable horizontally. We can have any number of chatbots and downstream processing scripts. It's also a fault-tolerant method of ingestion. For processing, we have Python, powered with Keras TensorFlow for our message counting and sentiment classification, and this information is outputted to Postgres. which is a data storage, SQL data storage that can easily be called by our UI and easily be written by a processing script. Finally, our UI is a Chrome extension powered with a Python Flask backend. So now on the throughput limitations of this project, each Node.js chatbot can produce 500 messages per minute. If you would observe the figure to the right, you can see that as we increase the number of chatbots from 1 to 3, the number of messages per minute increase at 500 messages per minute per chatbot. This changes as we reach 4 chatbots. Turns out that Twitch TV doesn't have any more messages for us to ingest, and increasing number of chatbots does not increase the performance, the throughput of our work. Now, the processing script processes 8,000 messages per minute, so our bottleneck will be mostly limited to the Node.js producer. But because of the Kafka architecture that we have set up, we can process any number of messages as long as we increase the number of nodes, either producer or consumer, to handle this job. Now, this avoids scaling vertically. This avoids us having to improve the performance of our computers and able to process an extra number of messages. So that's it for my project. Thanks for listening. I'm Lawrence Lai. I have a PhD in chemical engineering from MIT. As you can see, I'm a mad scientist to the right. In my off time, I also pursue martial arts, as shown in the video, and I'm a video gamer. Thank you for listening.